It begins with a circle, a shape so simple, yet hiding a secret so profound that it has fascinated minds for millennia. A number, neither whole nor rational, yet crucial to everything that turns, spins, or curves in our universe. So let's talk about pi. You know that weird little number that starts with 3.14 and keeps going on? It's one of those things that has been around forever, but it's way more interesting than just something you learn in math class. Believe it or not, people have been trying to figure out pi for over 4,000 years. The Babylonians were some of the first to give it a shot. They figured pi was about 3.125. Not bad, considering that they didn't have the tool that we have today. Just imagine they were working out this in the clay tablet. Then you've got Egyptians. They were all about pi too. Around 1650 BC, they used it to build the pyramids, and they got pretty close, estimating it about 3.16. Not perfect, but still impressive for the time, right? Now fast forward to ancient Greece. This is where things get really interesting. Archimedes, one of the greatest mathematicians ever, he figured out that by using polygons he could estimate pi much more accurately. He got it down to somewhere between 3.408 to 3.285, which was a huge leap forward. Then there was Sir Isaac Newton. Probably know him as a guy who figured out gravity, but he also did some serious work on pi. With his new calculus methods, he calculated pi to 15 places of decimal, and that's when pi really started getting precise. Today we have got it to a whole new level. With modern computers, we have calculated pi to over 202 trillion digits. Crazy, right? But here's the thing, even after all these time and all these digits, pi is still full of surprises. We haven't figured it out the exact value of pi. What's really cool about pi? That it's everywhere. The way planets move, in the patterns of the nature, and even how your, my, everyone's DNA is structured. It's like this little magic key that unlocks the secret of the universe. And that's what makes it so awesome to study and understand. Alright, now that we have geeked out the history, so what exactly is pi? Pi is the ratio of circumference of a circle to its diameter, and it has been calculated throughout the history. Let's put it to the test. We are going to try it out 3 different methods to calculate pi and see which one gets us to 3.141, which is 3 places after decimal, in the fastest way. Ready? Let's dive in. Here's the plan. We are going to use Monte Carlo method, Leibniz method, and the Archimedes method of calculating the value of pi. So let's start with Monte Carlo method. Now don't worry, it's not as fancy as it sounds. Basically, we're going to randomly throw virtual darts at square board with a quarter circle inside it. By counting how many darts drawn inside it, if you randomly place points inside the square, some of it will fall inside the quarter and some outside. The ratio of points inside the circle to the total points can be used to calculate pi. More the points we throw, the closer we get to the real value of pi. Now let's wire this bad boy up. We're going to connect the LEDs to Arduino Uno and then light it up as our approximation of pi gets more accurate. Each LEDs correspond to a digit after the decimal point. When our estimate hits a 3.141, the LEDs will tell us, and that's where the magic happens. But we're not stopping here. To spice things up, we are throwing in a servo motor. We will make it move based on how close our pi estimate is getting to the real deal. Think of it as a visual indicator of how well we are doing, like a little celebration every time we get close. With everything hooked up, we'll run the code that uses Monte Carlo method to calculate pi. As our estimates improve, the LEDs will light up one by one. As we get close to the value of 3.141, the servo motor will decrease its dance moves, and finally it'll stop, giving us the victory signal. This way you're not just seeing the numbers in the screen, you're using pi to come to life in front of you. So let's load the code and get started. We're going to have the Arduino generate random points and check if they are inside our virtual quarter circle and calculate our approximation value of pi. And so will the servo. It'll do its thing. And there you have it. We have calculated the pi using nothing more than some basic electronics and a bit of coding. Each LED lighting up tells us that we are getting closer, and when servo motor moves, it's like a little celebration of hitting the mark. Next we have got the Leibniz series. This one is a bit more straightforward. We are adding and subtracting fractions. 1 minus a third, plus a fifth, minus a seventh, and so on. It's like building pi out of Lego blocks piece by piece. This method converges to pi slowly, but it's classic. And finally, we have Archimedes method. Now this one's a throwback to ancient Greece. We're using polygons to approximate the value of pi. The more sides, the closer we get to pi. It's pretty clever, and for the time it was revolutionary. Now let's run all three methods and see which one gets us to 3.141 the quickest. So we're going to use the Arduino to crunch the numbers. We'll keep an eye on the LEDs and serial monitor to see which method hits the target first. This method got us to 3.141 the fastest. It just goes to show how different methods have their strength, and depending upon you are after, one might be better suited than other. While one method might be quicker, each one has its own unique approach to getting to pi. Whether you are into probability, series, or geometry, there is something fascinating about how these methods bring the ancient number to life. So next time you remember about pi, remember that it's not just a number, it's a whole journey through math, history, and even some hands-on electronics. Don't forget to like, share, and subscribe, and I'll see you next time around.